Our today's question is number of islands. So we have given a two-dimensional binary grid where the element is 1 and 0. 1 represent the land and 0 represent the water. It is similar to our previous questions, island perimeter. So like in this example, we can see there is a direct connection between these parts. So it is one island. So we output is one island. In second example, we can see there is a direct path, there is a direct path, and there is a direct path. So there are three island, means one is this island, second is this island, third is this island. We have given that it is surrounded by the water and formed by connecting adjacent land horizontally and vertically, means we can go adjacent can just line can go like horizontally and vertically. So like this is given. So we have to find total number of island that grid contain. So let's see how we will solve this problem. So we have to find number of component in this grid. Like this is one component, this is another component, this is another component. So if we find any element of the grid, means any element of the component, then we can go to its all connected component. Means if we find this path, then we can go there, there. On this we can go only this, and if we find any of this, then we can traverse between these. So we have to find number of components. To find the number of components, what we will do, we will make a DFS call. Like if we are at that component, means if starting from this, when we are at that component, what we are gonna go, we will make four direction DFS call. Means we can go to the up direction, we can go to the right direction, we can go to the bottom direction, we can go to the left direction. So if we are at this node, if we go to the left direction and bottom direction, then we will make a DFS call. First, what we are gonna do, we will make this node visited. We will make this node, we will make this node visited because we have already visited it and we do not need to traverse back to it again. So after this, we will go to the right side. So first we will go to the right side. Sorry, first we will go to the right side, then bottom, then left, then up direction. So here we go to the right side, we get to the one, we will mark it visited, and we will make a right direction call. So it is, we will go to the 0, it is not land, so we will return it. After that we will make down the DFS call, we go to this node, and this node is land. So again we will make a first we will mark it, then we will make a DFS call. We will go to this node, this is water, and we will return, we go to the bottom, this is water, so we will return, then we go to the left, it is land. So first we mark it and make a DFS call. It go to the right direction, in right direction the node is already visited, so we will return bottom water, so return left side boundary or water, so we will return per side, we will already cover the node, so we will return, then this call return to this node. So it has already made right, down and left call. After that, it will make the upper call. It is already widget, so it will return. So means for this part, we for this part we started from this, but we visited all this node. Means there are one iteration, means one island present. After that, we visit this node. We will check. We will check for another that is not visited. Like this is water, so we will not go. Then after that, we will check for this. It is not visited. Then our count will increase. Means every time when we get the non-visited, means any element of the component, then our count will increase. Means we found Iceland and we will mark its adjacent land and make them visited. So for one, it is no, so it will make four calls. Every call will be return nothing. After that, we reverse in this direction. Then we get this node. When we get this node, we will add a number of island. Then it will mark, it will visit this and this. So there is a direct path between this, direct path between this, direct path between this. So this will be our approach. We will make a DFS call, means we will make four condition, four DFS call, one for one DFS call for I minus one and j, other for I plus one and j. Then I j minus one and I j plus one. This will be our four DFS call. So let's see the code, how we will solve it. So this is our code. First, we created a variable count 0, which will be the number of island. We will iterate in the grid I from 0 to less than grid length, means in row, in column. If we found the land, then we will make a DFS call and we will add count plus 1. Means it is land and it is not visited. Like for this example, if I show this example, first it is land, means there are value of 1. There are value of 1. After we get to this value, there is also value 1. We make a DFS call. So for this DFS call will be make, and after making DFS call, it is visited and its all node that present in the Iceland is visited. So what we are gonna do, we will not create another variable, means we will not create another space for this. We will modify the given array. So if it is visited, so we will change it to 2. We will change it to 2, and this will also converted to 2. This will also converted to 2. This will also converted to 2. So every node of this element will be converted to cube. So first time, if node is 1, means it is the land and it is not visited, then we will make a DFS call for this node and we will add number of island plus 1. So let's see the DFS function. We will pass grid and row index and column index. This is our base condition, means we will, for here, we will not fall less than this, or we will not jump to the boundary for this. So we have made boundary condition means if rho is less than 0, I less than 0, or I is greater than grid dot length, or j less than 0, or j is greater than grid I of length, then we will return. Or other condition is if we get to the water means if we go to this part, then we will return. Or if we go to the node that is already visited, then we will return. So if we go to the, if grid of ij equal to 0 means it is a water, so we will return. Or grid of ij equal to 2 means the node is already visited, then we will also return. Otherwise we will set the node value to the 0, means currently value is 0 1. After we visited the node, we will set its value to 2. Then we will make 4 DFS call. First for I plus 1 means this is for down, I minus 1 for up, it is j minus 1 for left, and it is j plus 1 for right. So this is our code. If we run it, means we submit it, 86%. It is a pretty good approach. So if we talk about its complexity, when space is big of n into m, space complexity n into m, because we are not creating any other, and at most in the stack all values can be filled means all values are 1, so all values can be filled. So this is space complexity. For time complexity, the time complexity will be n into m, means traversing a array one by one, plus for every DFS. For every DFS call, means for every DFS call it will at most travel n into m. So our overall time complexity will be we go of n into m. So this is our worst case time complexities. So good approach, we need almost n cross m to traverse in the grid. So that is the solution for today's problem. Thank you.